Section 04. Problem 01. Problem statement. Generate or load a dataset suitable for classification tasks. Skills required: basic data manipulation and understanding of classification datasets. Instructions. Generate or load data for classification. Prepare the data for TensorFlow processing. Algorithm. Import necessary libraries. Create or load dataset. Split data into features, X, and target labels, Y. How code is working: the code generates a synthetic classification dataset with 3 classes using make_classification. The dataset is then split into training and testing sets, suitable for training and evaluating a classification model. Problem 02. Problem statement. Create and define a logistic regression model for multi-class classification in TensorFlow. Skills required: understanding of TensorFlow model definitions and logistic regression. Instructions. Define placeholders for input features and labels. Define the model parameters, weights and biases. Implement the logistic regression model. Algorithm. Import TensorFlow. Define placeholders for X and Y. Initialize weights and biases. Define the logistic regression model using softmax activation. How code is working: the code defines a logistic regression model with a softmax activation function to handle multi-class classification. Placeholders are used for features and labels, and the model parameters are initialized. Problem 03. Problem statement. Use the softmax function to compute probabilities for multi-class classification. Skills required: understanding of softmax activation and multi-class classification. Instructions. Apply the softmax function to the model logits. Compute the predicted class probabilities. Algorithm. Apply tf.nn.softmax to the logits. Obtain predicted probabilities for each class. How code is working: the softmax function converts the raw model outputs, logits, into probabilities for each class. tf.argmax is used to determine the class with the highest probability. Problem 04. Problem statement. Calculate the cross-entropy loss for the classification model. Skills required: understanding of cross-entropy loss and TensorFlow operations. Instructions. Define the cross-entropy loss function. Compute the loss between predicted probabilities and actual labels. Algorithm. Convert class labels to one-hot encoded vectors. Calculate the cross-entropy loss using TensorFlow. How code is working: the code calculates the cross-entropy loss using TensorFlow's built-in function tf.nn.softmax_cross_entropy_with_logits_v2. It compares the predicted probabilities to the one-hot encoded true labels. Problem 05. Problem statement. Train the logistic regression model and evaluate its performance using accuracy. Skills required: model training and evaluation in TensorFlow. Instructions. Define the optimizer for training. Train the model on the dataset. Evaluate the model's accuracy. Algorithm. Define an optimizer, example gradient descent optimizer. Perform training in a TensorFlow session. Compute accuracy by comparing predictions to true labels. How code is working: the code trains the logistic regression model using gradient descent and computes accuracy by comparing predictions to actual labels. Training and evaluation are performed within a TensorFlow session. Problem 06. Problem statement. Visualize decision boundaries of the trained classification model using matplotlib. Skills required: data visualization using matplotlib and understanding decision boundaries. Instructions. Define a function to plot decision boundaries. Visualize the decision boundaries along with the data points. Algorithm. Create a mesh grid of feature values. Compute model predictions across the grid. Plot decision boundaries and data points. How code is working: the code plots the decision boundaries of the trained model. A mesh grid is created over the feature space, and predictions are computed to visualize how the model separates different classes. Data points are then plotted on top of the decision boundaries. Section 05. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about neural networks and TensorFlow. In this section, we'll explore the foundational concepts of neural networks and how to implement them using TensorFlow. Here's what you'll be diving into. Article. We start with an article that discusses neural networks and TensorFlow. This article will guide you through the basics, supported by examples to enhance your understanding. If you have any questions or need clarification on any part of the article, feel free to message me directly. Assignment. Topic: Create a basic neural network for classification. Details: This assignment will challenge you to build a simple neural network for a classification task. It includes detailed instructions on how to approach the problem, solution hints, and steps to follow. After completing the assignment, you can submit it to me for feedback. Coding exercises. Define a neural network architecture, learn how to structure your neural network, including selecting the number of layers and neurons. Initialize weights and biases, practice setting up the initial parameters that your network will use during training. Implement forward propagation, understand how data flows through the network to make predictions. Compute loss and perform backpropagation, learn how to calculate the error in predictions and adjust the network to improve accuracy. Train the neural network with a dataset, gain hands-on experience in training your neural network with real data. Evaluate and improve model accuracy, explore methods to assess your model's performance and techniques to enhance it further. A video accompanies these coding exercises, providing you with detailed explanations, solutions, algorithms, and the necessary skills to complete each task. After completing this section, you will be able to define and structure a neural network architecture. Initialize the necessary weights and biases for your network. Implement forward propagation to allow your network to make predictions. Compute loss and apply backpropagation to optimize your model. Train a neural network using a dataset. Evaluate your model's accuracy and apply strategies to improve its performance. If you have any questions, confusion, or issues, please don't hesitate to message me. I'm here to help you succeed. Section 05. Problem 01. Problem statement. Design a neural network architecture for a given dataset. Skills required: understanding of neural network architecture and TensorFlow layers. Instructions. Define the neural network's layers and architecture. Specify the number of neurons, activation functions, and output layers. Algorithm. Import TensorFlow. Define placeholders for input features and labels. Construct the neural network layers. How code is working: the code defines a simple neural network with two hidden layers. tf.layers.dense is used to create fully connected layers with ReLU activation for hidden layers and no activation for the output layer, suitable for multi-class classification. Problem 02. Problem statement. Initialize the weights and biases for the neural network layers. Skills required: understanding of weight initialization techniques in neural networks. Instructions. Initialize weights and biases for each layer. Use appropriate initialization methods. Algorithm. Use TensorFlow's built-in initializers for weights and biases. Initialize these variables before training. How code is working: TensorFlow's tf.layers.dense function automatically handles weight and bias initialization. Therefore, no explicit initialization is needed for weights and biases. Problem 03. Problem statement. Perform forward propagation through the neural network. Skills required: understanding of forward propagation in neural networks. Instructions. Define the forward pass through the network. Compute predictions based on input data. Algorithm. Pass input data through the neural network layers. Obtain predictions. How code is working. The neural_network function defines the forward propagation process by passing the input data through successive layers to obtain the logits, predictions before applying softmax. Problem 04. Problem statement. Compute the loss function and perform backpropagation to update weights. Skills required: understanding of loss functions and backpropagation in neural networks. Instructions. Define the loss function. Set up the optimizer for backpropagation. Algorithm. Compute the loss using TensorFlow's loss functions. Apply an optimizer to minimize the loss. How code is working. The cross-entropy loss is computed using TensorFlow's tf.nn.softmax_cross_entropy_with_logits_v2, which compares the predicted logits to the true labels. The atom optimizer is used to minimize this loss through backpropagation. Problem 05. Problem statement. Train the neural network using a dataset. Skills required: model training and session management in TensorFlow. Instructions. Initialize variables and start a TensorFlow session. Run the training loop with data. Algorithm. Initialize TensorFlow variables. Run the training operation over multiple epochs. Feed data into the training process. How code is working. The code initializes TensorFlow variables and trains the neural network over several epochs. The training loop processes data in batches, updating weights using the optimizer. After training, the model's accuracy is evaluated on the test set. Problem 06. Problem statement. Evaluate the model's accuracy and make improvements. Skills required: model evaluation and optimization techniques. Instructions. Evaluate the model's performance on the test set. Experiment with techniques to improve accuracy. Algorithm. Calculate accuracy on the test set. Modify hyperparameters or architecture to improve performance. How code is working. To improve accuracy, you can experiment with various strategies such as tuning hyperparameters, altering network architecture, or applying regularization techniques like dropout. The provided code snippet adds dropout layers to the network to help prevent overfitting. Section 06. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about convolutional neural networks, CNNs. This section is designed to introduce you to the powerful world of convolutional neural networks, or CNNs, a crucial technology in modern image processing and computer vision tasks. Here's what you can expect. Article. We begin with an in-depth article that discusses convolutional neural networks, CNNs. The article includes examples to help you grasp the concepts effectively. If you have any questions or need further clarification on any part of the article, feel free to message me directly. Assignment. Topic: build a CNN for image classification. Details. In this assignment, you will build a convolutional neural network to classify images. I've provided detailed instructions on how to approach the task, along with solution hints. Once you've completed the assignment, you can submit it to me for feedback and evaluation. Coding exercises. Implement convolutional layers in TensorFlow. Learn how to create convolutional layers that form the building blocks of CNNs. Add pooling layers to reduce dimensionality. Understand how pooling layers help in reducing the size of feature maps while retaining essential information. Build a CNN model for the NIST dataset. Practice constructing a CNN model tailored for the NIST dataset, a classic dataset for handwritten digit recognition. Train the CNN and evaluate performance. Gain experience in training your CNN model and assessing its accuracy. Visualize feature maps and filters. Explore the inner workings of your CNN by visualizing the feature maps and filters it uses. Fine-tune the CNN model for better accuracy. Learn how to improve your CNN model's accuracy through fine-tuning techniques. You can watch the accompanying video where I walk you through these coding exercises, including their solutions, algorithms, and the skills required to complete them. After completing this section, you will be able to implement convolutional and pooling layers in TensorFlow, build and train a CNN model for image classification tasks, visualize and understand the inner workings of a CNN, fine-tune your CNN model to improve its performance. If you have any questions, confusion, or run into any problems, please don't hesitate to message me. I'm here to help you succeed. Section 06. Problem 01. Problem statement. Define and implement convolutional layers in a neural network for feature extraction. Skills required: understanding of convolutional operations and TensorFlow's convolutional layer functions. Instructions. Define convolutional layers with specific filter sizes and strides. Use activation functions like ReLU. Algorithm. Import TensorFlow. Define convolutional layers using tf.layers.conv2d. Apply activation functions. How code is working: the code defines a convolutional layer with specified filters and kernel size using tf.layers.conv2d. ReLU activation is applied to the convolutional output. Problem 02. Problem statement. Add pooling layers to the CNN model to reduce dimensionality and computational complexity. Skills required: understanding of pooling operations and TensorFlow's pooling functions. Instructions. Implement pooling layers to reduce the spatial dimensions of feature maps. Algorithm. Use tf.layers.max_pooling2d for max pooling. Specify pool size and strides. How code is working: the max pooling layer reduces the dimensions of the feature maps by taking the maximum value in each pooling window, thereby reducing computational complexity. Problem 03. Problem statement. Construct a complete CNN model for image classification using the NIST dataset. Skills required: building and combining convolutional and pooling layers into a complete model. Instructions. Define the complete CNN architecture. Include convolutional, pooling, and fully connected layers. Algorithm. Define convolutional and pooling layers. Flatten the output from pooling layers. Add fully connected layers and output layer. How code is working: the CNN_model function defines a CNN architecture with two convolutional layers, each followed by a pooling layer. The output is flattened and passed through fully connected layers before producing logits for classification. Problem 04. Problem statement. Train the CNN model using the NIST dataset and evaluate its performance. Skills required: model training and evaluation in TensorFlow. Instructions. Define the loss function and optimizer. Train the model and evaluate accuracy. Algorithm. Define loss function, cross entropy. Define optimizer, example atom optimizer. Train the model and evaluate accuracy. How code is working: the code trains the CNN model over several epochs using the NIST dataset. The loss is computed using cross entropy, and the optimizer updates the model weights. After training, the model's accuracy is evaluated on the test set. Problem 05. Problem statement. Visualize feature maps and filters learned by the CNN. Skills required: understanding and visualizing feature maps and filters. Instructions. Extract and visualize feature maps and filters. Plot the results using matplotlib. Algorithm. Extract feature maps from the convolutional layers. Plot the filters and feature maps. How code is working: the code extracts and visualizes feature maps from the convolutional layer. It also visualizes the learned filters from the first convolutional layer using matplotlib. Problem 06. Problem statement. Improve the CNN model's accuracy through fine-tuning. Skills required: hyperparameter tuning and model optimization techniques. Instructions. Experiment with different hyperparameters, example learning rate, number of filters. Adjust network architecture and training procedures. Algorithm. Modify hyperparameters or network architecture. Retrain and evaluate the model. How code is working. The code updates the CNN model by adding more layers and adjusting hyperparameters. The model is retrained and evaluated to check improvements in accuracy. Section 07. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about recurrent neural networks, RNNs. This section is dedicated to understanding recurrent neural networks, or RNNs, which are essential for processing sequences and time series data. Here's what you can expect from this section. Article. We start with an article discussing the key concepts of recurrent neural networks, RNNs. This article includes practical examples to help solidify your understanding. If you have any questions or need clarification on any part of the article, please feel free to message me directly. Assignment. Topic: Implement an RNN for sequence prediction. Details: in this assignment, you will implement an RNN for sequence prediction tasks. I have provided detailed instructions, along with solution hints, to guide you through the process. Once you have completed the assignment, you can submit it to me for feedback. Coding exercises. Define an RNN architecture in TensorFlow. Learn how to design the architecture of an RNN using TensorFlow. Work with sequences and time series data. Understand how to handle sequential and time series data in RNNs. Implement LSTM cells for long-term dependencies. Gain experience in implementing LSTM cells to capture long-term dependencies in data. Train the RNN model on sequential data. Practice training your RNN model on sequential data sets. Predict future values using the trained RNN. Learn how to use your trained RNN model to predict future values based on the sequence data. Evaluate and visualize RNN predictions. Explore how to evaluate the performance of your RNN and visualize its predictions. You can watch the accompanying video where I walk you through these coding exercises, including their solutions, algorithms, and the skills required to complete them. Section 07. Problem 01. Problem statement. Create a basic RNN architecture to process sequential data. Skills required: understanding RNNs and TensorFlow's RNN layer functions. Instructions. Define the RNN layers using TensorFlow. Specify the number of units and the sequence length. Algorithm. Import TensorFlow. Define RNN layers using tf.keras.layers.simplerNN or tf.keras.layers.lstm. Add output layers for prediction. How code is working. The RNN_model function defines an RNN with a specified number of units. It processes sequences and produces predictions using a dense output layer. Problem 02. Problem statement. Prepare and handle sequential data for training an RNN. Skills required: data pre-processing and handling of time series data. Instructions. Load and pre-process time series data. Format data into sequences suitable for RNNs. Algorithm. Load the data. Split data into sequences and labels. Normalize the data. How code is working. Data is normalized and converted into sequences where each sequence has a length of sequence_length. Labels are the values that follow each sequence. Problem 03. Problem statement. Use LSTM cells to capture long-term dependencies in sequential data. Skills required: understanding LSTM cells and their implementation in TensorFlow. Instructions. Define LSTM cells in the RNN model. Ensure the model handles long-term dependencies effectively. Algorithm. Replace simple RNN cell with LSTM cell. Train the model with LSTM cells. How code is working. The LSTM_model function replaces the RNN cell with an LSTM cell, enabling the model to capture long-term dependencies in the data. Problem 04. Problem statement. Train the RNN model using the prepared sequential data. Skills required: model training and evaluation using TensorFlow. Instructions. Define the loss function and optimizer. Train the model with sequential data. Algorithm. Define loss function and optimizer. Train the model using data sequences. How code is working: the model is trained over several epochs using sequential data. Loss is computed with mean squared error and minimized using the atom optimizer. Problem 05. Problem statement. Use the trained RNN model to make predictions on future data. Skills required: model inference and prediction with TensorFlow. Instructions. Use the trained model to generate predictions. Handle new sequences for prediction. Algorithm. Feed new sequences to the model. Obtain predictions. How code is working: the model generates predictions for future values based on the last sequence of the data. Predictions are obtained by feeding new sequences into the trained model. Problem 06. Problem statement. Evaluate and visualize the predictions made by the RNN model. Skills required: evaluation metrics and visualization using Matplotlib. Instructions. Compare predictions to actual values. Plot predictions and actual values. Algorithm. Compute evaluation metrics, example mean squared error. Plot the actual versus predicted values. How code is working: the code plots actual versus predicted values to visualize the performance of the RNN. This helps in evaluating how well the model is capturing the patterns in the sequential data.